Tyler is joining me to show us, everybody here, how sick Mewgenics source code is. Because there are some nasty things. That's what he's been telling me. And I am super happy to see the crazy things that power this game. Because like the things you can make in this game require an interesting approach from the source code, I presume. So I'm super happy and excited to see what's actually inside.
All right. Should put a disclaimer for C programmers. They might find some of this content disgusting or offensive to them.
And if anybody is here and has no idea what Mewgenics is, stop, Google Mewgenics, go to Steam, download the game, buy the game, download the game, play the game, and come back. Okay? Come back if you can, if you're not sucked into the void of Mewgenics.
We knew it was going to be a long project, so we were able to plan for the scope of this ahead of time, at the start, and I think that helped a lot in architecting the whole thing. Usually you don't have that sort of luxury when you're making a game. Usually you're like, well, we'll make something and we'll see where it goes and see how big it'll get over time and adjust as necessary. But yeah, we could plan from the start.
But you also experimented with genre for some time, right?
Yeah.
So you mean that after you locked down the genre, you knew that you have years of development and you can start fresh, or was it even before?
It was sort of we knew it was going to have a lot of stuff in it, but it wasn't until we locked it down on the genre that I'm talking about. But there was a lot of experimentation in the earlier prototypes, which I don't think I can show those right now because I would have to dig through ancient SVN history to find them. I have them somewhere, but there was a lot of some of the systems in here are branched off of some of the experiments, what did or didn't work in the prototypes that were different genres, but for the most part it was deleted and restarted at that point. And then also people should understand before I just immediately show some code that I know how programmers are. I know they're going to be like, oh, why didn't you do it this way? Why is this block copy pasted 5 times across 6 different files? And it's at the very start of a project, your code should be messy because you're just trying to get stuff on the screen. At the middle-ish point of a project, past the prototypes, I try to have my code be good and solid, as good and solid as possible. Just make a solid foundation to build everything else off of and make sure that I'm fitting stuff into the way that I've coded it instead of trying to just bend everything around itself and turn it into spaghetti. Then towards the end of a project, you just have to get it done. So fuck all that. Just throw random bullshit at the screen. Everything that people are like, oh, this is bad, you should never do this, it'll come back. I don't like exceptions and throw and try and catch and stuff. Most programmers don't really like that kind of stuff. When I had to go fix this whole save file corruption thing, which I was I just got 1 day to do this. I'll just wrap the fucking file loading in a try and catch, and then if it throws an exception, I can say the file was corrupted. There's little things like that where it's okay, maybe there would have been a cleaner, more robust way to do that, but once it's out and it's just got to get shit done, there's easy ways to do things. Anyway, let's see how I can share my screen on here.
In the meantime, there is already a question. Had you considered another language than C++?
No. And the reason why is because The End Is Nigh was written in C++, and it's the same engine. Basically. I mean, it's a newer version of the same engine, but a lot of the code is reused from that.
Hi everyone. Let me take a break to thank members of the show who made this conversation possible. Members get earlier access to videos, including longer unedited footage from live streams, as well as they're invited to our private Discord server. If you want to support the show, there is no better way than becoming a member on YouTube or Patreon. Thank you so much. What a theme for Visual Studio. Damn.
Yeah, I like my color themes. I spend a decent amount of time tweaking it. It's not just solarized, like there's other stuff. Anyway. C++, right? Yeah. Did I consider other languages? In the future, like I think I'm still using C++ in the future. I want to learn at some point. I want to learn John's language, and I want to learn Rust. I don't know if I would do anything big in either of them, but I do like just learning like how other languages approach things. But one of the reason why I use C++ is because there's billions of lines of code for it already written, and like billions of libraries that are made for C++. It works with everything made for C as well. Compiles and runs on everything, and it's fast enough that like if you have issues, like if you have a performance issue, you can usually fix it. But there's just a lot of like, game was 6 years in development, but there's C++ code in here that's 15 years old. So.
Yeah.
Yeah.
Okay. And you keep this in your mind, like still. And people.
Like keep what? Like the 15-year-old code?
For people who don't know, Tyler is like sole programmer on Mewgenics. Like.
Yeah. Oh, well, we had another programmer working on items as well, but for the engine is mine, and the vast majority of the C++ code is mine. But the other programmer had put a few pieces in here.
How big is it? Do you know? Like lines/files?
Unfortunately, the technology in Visual Studio does not exist to give you that number.
I mean, it's a complex task, You wouldn't know where to begin with.
I think it is probably 200 or 250,000 lines of C++, and maybe the same amount of like these sort of gone data files, which are this is my own thing. There's a lot of this kind of counts as code, but there's a lot of this is structured data.
It's like
probably another 250,000 of that.
Like config files, sort of like, right?
Yeah, it's sort of what I called it gone for Glaiel object notation. It's modeled slightly after JSON, but a bunch of unnecessary stuff removed. So like JSON would require you to put like all this shit in like quotes like that or whatever, and would require you to be like that, like equals or whatever. I just figured the less symbols, the better. And this sort of matches the way that you do like key value pairs in like a .ini file or whatever. And I have this is open source. I've posted the Gone source on GitHub, but it also just like it'll ignore like parsing stuff that is unnecessary. So you should, I don't know if this actually works or not, but you should be able to like throw a JSON file at it and have it load.
Oh, okay.
But I don't do that. Anyway. So I think there's 250,000 lines of C++ and like 250,000 lines of that at one point. I think that's what I measured. It's not huge. It is the largest project that I've worked on in terms of lines of code, but like I've known about other projects that are significantly smaller than this game and have like 800, 900,000 lines of code.
That's, I would say, like to have all the complexity built in from such a expansive game, it's quite wild.
Yeah.
to have this. My project at work is like 4 tabs and it's 250k. So same size. And it's,
Yeah.
how much, I need to ask this, how much time does it need to compile?
Let's see here.
1, 2.
That was cleaning it.
Okay.
You look over here. I believe it takes about 45 seconds on my computer.
You're sharing the screen now, so it might be slower.
Yeah, I don't know if that would affect the compile speed. Right now, the only thing that affects my performance is this fucking NVIDIA broadcast thing, which like makes moving windows around choppy. Because I think it uses up like most of the GPU to blur the background of my webcam.
Oh yeah.
Yeah.
By the way, what are the parts that you wanna showcase from the engine? Just like high level. Do you have a list? Do you have a thing?
Oh yeah, we can showcase some stuff. It's still compiling because this is C++. This is also a full rebuild. And 122,000 functions is a lot.
122,000
okay, it's linking
functions.
Compiled. Yeah, there's a bunch of there's a few template explosions. Okay, there we go. That was like a minute. That's not, for C++ terms, that's not that bad for a full rebuild.
Yeah.
Oh man, it's running like shit because of fucking NVIDIA broadcast. Oh
yeah. Also,
there's a ton of spoilers on this screen, by the way. So, which the game's out, so I don't care about that anymore. But yeah, close your eyes if you have not played the game. But yeah, that's about how much. That's a full rebuild. I do a lot of C++ gives you tools to speed it up, like precompiled headers, and I absolutely use those because without those, it would take 5 minutes. It's not a good solution. People complaining about C++ are usually correct, but you do have to, if you're using C++, you got to deal with it, and it gives you these stupid ass tools like precompiled headers that are meant to solve a problem that it could easily solve in other ways if they wanted to. I guess they tried to with modules, but those also just don't work. But
precompiled headers, are they in all C++ toolchains? Or because MSVC for sure, because they invented the thing. But the other toolchains, either it's recent or they're just not there yet.
I think I only use Visual Studio, so
okay.
Whatever. But the precompiled header does what it's supposed to do. A lot better than modules, which I could not get this compiling with modules enabled. I tried.
And this was
I don't understand.
And this was also release build, meaning it will spend more time on doing the optimizations, at least in theory, so that you have a perfect output.
Yeah. I think the release build might be faster than the debug build to compile. There's some weirdness there. I think there's a link time optimization where it, I've profiled this before. There's something where when it is allowed to optimize after the program links, it can defer a whole lot of stuff to that point and avoid doing redundant things. And then when you're trying to do per file, if you're doing debug, or if you have that disabled and you're trying to let it only optimize every individual file, it does a bunch of extra work. I don't really understand what makes the compiles take so long. You can profile it, there are tools to do that, but for the most part, that was a full rebuild. If I just change this to 0.75, which is one of the changes we actually do want to make, and I do a not full rebuild, it doesn't take nearly as long to do.
It should compile.
There's also a couple of Python scripts that run on my build step as well. It's already linking at this point.
What do they do? The Python scripts.
The Python scripts. Let's see. This is probably a good point to start. C++ doesn't have reflection, so I guess it does now, but I don't think that's launched yet. So let's say basic like status effects or whatever. So like this macro here, component, and the word status, like there's yeah, let's see.
You have
Component types
custom
like this.
resolver of macros. Like for you have Python scripts that resolve your macros.
No, it scans for this macro and then takes this word and puts it into this enum.
Okay.
So I have this like enum of every possible component in the game, and then some macros that represent like inheritance hierarchies for them. So like this file right here is probably this file. There you go.
Oh wow. Okay.
Yeah. So like this is not a human written file. These are I just need everything needs to be in this enum, and then it needs to be these like A macros, which I think other people use X for this to call them X macros, but like let's see, enumerate child of status. Like every status effect in the game is listed here, so that when I want to like if I have a passive I'm jumping around in a lot of places, but like if I have say a monk passive that says crits apply status confusion 1, these are text files, so the game has to map the word confusion to the status effect confusion somehow. So the way it does that is construction helpers, there's something like apply status in here somewhere. It's very hard to find this when I'm zoomed in like 200%. So like attach passive, just it runs, it enumerates over all the passives and finds the one that was named confusion and then attaches that one to the thing.
But the GAN files, they are being built into like C++ objects, or they're being scanned as
no, these are
files?
Data files. They're text files. Yeah.
Okay, so they
so
remain
I get when I load confusion as a string, right?
Okay.
Yeah.
Okay.
And then you need some way to map the text string confusion to add the confusion object onto the character, or like the confusion status effect onto the character, and then that's what this like helper file along with why did it change the coloring of this? What is wrong with Visual Studio? This is a macro and this should be this color. It was that. I'm not crazy. It was the right color the last time I looked at this file, right?
I don't know. Was it?
It was. It was definitely the right color the last time I looked at the file. Oh, the color's gone from this file now.
Yeah, exactly.
Great. I love Visual Studio.
So, do I understand correctly that you have like a version of an ECS as a core architecture for ECS, like Entity Component System?
Oh, ECS.
Yeah.
It is not full. It's entities and components, but it's not ECS. It's closer to the way that like old Unity would do it, where you have an entity with components attached to it. But I don't have system as its like own type. All the components just have their own code attached to them.
So how generally the core loop looks like? Like if you can imagine, like generally speaking, games are like, hey, here's like initialization stuff, and then we enter this while, and we have like a frame, right? And then a tick, and then we do a bunch of things with like update, and then we do rendering, right? And this update thing, how does it look like?
let's see. I have this application is sort of the like main base of it, where I have like initializing systems and stuff, and then there is. Oops. Accumulate time. Like this is in a shipped game, it's more complicated than just like a while loop, because there's a lot of timing stuff. So no, not accumulate time, consume time. So once I have delta time, I believe this is the one that I'm using for Mewgenics, which is the unlocked tick. So it just I do a fixed update once every 60 or like 60 hertz. I do a fixed update. Unlocked update, I make sure that I do at least one of these every fixed update. A fixed update is going to be flat 60 hertz. So every delta time during a fixed update is going to be 1/60. Unlocked update is going to be, the delta time is going to be the actual time. So like if the game, in my case, my monitor is 144 hertz. So I'm going to get 144 unlocked updates with 1/144 hertz, and then it'll render when it's done doing that.
Okay, so you accumulate time in a variable, so that whenever it's like 1/60, you have the fixed one.
Yeah,
but you
whenever
also,
it's 1/60, I get the fixed one.
Yeah,
and then every time the game wants to render a frame, I do an unlocked one and a render. And I also do an unlocked one every fixed one, because I don't want, you want these to kind of remain in sync. Like you don't want to, like it's easier to think, oh, I could put logic in unlocked update and not have it missed if the game is running 20 frames per second, right?
Yeah.
So if the game's running 20 frames per second, it's going to do 3 fixed updates before it renders. So you want to make sure that you get 3 unlocked updates in there as well, and then it'll do the excess time that was missing from that before rendering. This is one of the hardest problems in game dev, ironically. Like you'd think that this is an easy solved problem, but it's not. And I'm not fully happy with this solution for it.
And it also changes when you want to have like arbitrary runs, modify the speed of the game, right? Because it's one thing to make it work on like 60 and that's it. But then like if you want a speeded up version of the game to run blast through some sort of scenarios, then it's annoying.
Yeah. I handle that on a different, like for accumulate time, I think. Time scale, where I can just change the delta time by the time scale, and then eventually that makes its way down to the tick function. But there's like a frame pacing is a whole can of worms. I have like a thread on the SDL repository trying to figure out a better solution for it. One of the problems is that when you measure time in Windows, because of scheduling, like thread scheduling, it can just randomly be offset by like 3 milliseconds.
What?
Yeah.
Okay.
I mean, it was just, and because what happens will, like, you'll ask to measure the time. The thread scheduler in Windows will be like, oh, I'm going to just pause and do this other thread for a bit and then come back to it. So your time measurement will then be 3 milliseconds off where you want it to be, and it makes up the next loop, because the next loop through it might not have the bubble, so then you end up with one that's like 3 milliseconds early. So you get this like weird heartbeat pattern when measuring time, even though over the long period it averages out to be real time. That your measurement can just be off in Windows and most operating systems, I think. So there is. This is
3 milliseconds.
Annoying issue.
3 milliseconds. That's a lot.
Yeah, it is a lot. I don't know what Windows does sometimes. I think it's actually closer to 1 millisecond, but I think it was. It shouldn't be more than 1 millisecond, but you never know what your computer's doing.
Okay.
even then, a millisecond is a large portion of the frame time when you're running at a high frame rate. Like, if you're running at 200 frames per second, you have 5 milliseconds per frame. So that 1 millisecond is like a 20% difference in frame time. The thing is that this is just a timing, this is a measurement difference. The game is not running slow. So the monitor does not have this issue. So if you're sending an update as fast as you can and you have VSync on, you're going to be presenting frames at a consistent rate. It's just that your time measurement between those frames when you call like get ticks or whatever from the operating system, that is inconsistent. But if you're trusting that inconsistent measuring too much and you're adjusting your game's frame time to that measurement, the monitor is still displaying them at a consistent, like correctly paced rate, but you are rendering them at the wrong rate, so the game will be choppy. Yeah, someone mentions the Fix Your Time Step article. That is not the full solution. That is a pretty basic, like, this is, if everything worked correctly, this is how you would do it. But when you run into real world situations like this. Like, there's a thing, like, if you know your game is running fast and you know that it is V-synced at 60 frames per second, you can just assume that every update is going to take exactly 1/60th seconds to do. And that is the rate that you should be presenting frames. If you're adjusting that forward and backwards at all, then the monitor is still going to display at 60 and it's going to be choppy. So you can't fully rely on the measurement. And like a lot of games will like do this by averaging it out over time. But those hiccups will still have a small impact when you're averaging out over time, and it might not be as smooth as it can be. Newer, like Vulkan and DX12 have some ways to get the actual like displayed frame time, and from the graphics adapter itself. That still has this timing bubble that I've noticed. Like, it is still sometimes wrong for the actual time, but it will tell you the number of frames that it has displayed. So some of what I'm doing here is that I try to detect if VSync is running, which is also, the game knows if it wants VSync to be on, but people can change that in their graphics driver settings to like force VSync on or off. And the game has no way of telling if they've done that unless I like link in like the NVIDIA what do they call it? there's like an NVIDIA API to like read the graphics driver information directly, which I have not put in here. But if they change that, then I don't know, the game will think it's VSynced, but then it won't be VSynced because they changed it in the graphics settings. So what I have to do is I basically have to measure, like, if the game thinks it's VSynced, it uses a VSync timing. And then if the time that the real time drifts from the expected time by too much, it goes, oh, I must not be VSynced, and then it switches to the averaging measured time. I think. I don't know if I actually put that far. I don't know if that ended up shipped in this game or not, but I have like a version of my timing thing that does that.
You can tell that you shipped a big game because you know all this edge cases of what can people have their setups and what nasty things that you can run into that nobody would ever know if they wanted to just like, oh, it's my personal project.
This is why, why they always tell you to update your graphics drivers as like your first debugging like step when people have issues. It's because usually if you do it by the normal flow, it'll reset your settings to default. And that will fix most issues that you have with graphics in games. Because a lot of what the graphics driver is doing, it does not communicate that back to the game that you're running. So like anti-aliasing is a big one, like MSAA. This one I figured out. I had this issue with the nDesign, fixed it there, so I shouldn't have that issue here. But the way that the game works is that it will render to an off-screen texture and then blit it onto the back buffer, so that it can do letterboxes and stuff. The blit operation requires that there's like a whole like chart of what is compatible with what for like a frame buffer blit, and if the sizes match and the anti-aliasing match, it can just basically be like a mem copy. If they if the sizes don't match, you have to like go to an internal one first, and then or like the sizes and anti-aliasing. There's like a big chart. I basically had to make like a square and put like anti-aliasing on one side and do the sizes match on the other and just test to see which ones would show up as a black screen and which ones would work. There's some documentation for it, but it doesn't seem the most accurate. Either way, the point of the matter is that I need my back buffer to not have anti-aliasing on it. Because the frame buffer that it prepares has the anti-aliasing resolved in it already, and then it just prints that to the back buffer. If you override your graphics card settings to have MSAA forced on, that back buffer will have MSAA on, even if you don't want it to have that on. And that will be a black screen if you're doing anti-aliasing in-game that doesn't exactly match or like, I guess I do resolve it down to no anti-aliasing before blitting it onto the back buffer. But either way, if they've changed the setting to put anti-aliasing on in the back, that operation doesn't work, and you have to use a different path to do that, where you have to like use an extra internal texture to do it, where you blit it to that texture before blitting it to the screen. And there's certain settings that need to match between each of those steps. And so it is slower if they do that. That's why I'm like, turn off, like, don't just set everything to let the application decide in your graphics card settings.
What I take away from that is I shouldn't mess with NVIDIA control panel. I should use only what the game provides as a setting for graphics, because that's like, that's asking for problems.
Yeah, at least for an indie game where I'm like one person writing this stuff and you don't have like a team of engineers to decipher all of these issues for you. There is one NVIDIA setting that I do think people should have on, which is it's like OpenGL present mode, where you switch it to layered on DXGI swap chain, and that will fix like borderless windowed stuff. Because this game, at least this version of SDL that I'm using, it does request a borderless window, but NVIDIA and Windows decide, oh, full screen borderless window, this must be a full screen exclusive window, and then they like treat it like that unless you have that setting set in NVIDIA settings.
Nice.
But yeah, and most of the stuff that's like anything that would change the graphics, like anti-aliasing or VSync or whatever, let the game decide. Don't like it is annoying to
let the game decide.
Let the game decide, because the game needs to know these things to do timing stuff correctly.
Nice. So
yeah,
this was all just on the from the topic of timestamp, and we still need to go through the fixed update to see the components and entities.
Do fixed update setting. Why am I saving the settings every fixed update? Oh, there's a flag, so it's just doing nothing every time. This is a callback for like the game specific application callback, and then I have this profiler that just tracks some timing stuff. The director.update is where the actual update happens. So like the structure I have is that I have a thing called a director. I'm not going to draw diagrams actually. But I have a director, and then I have scenes, and then within the scenes I have components. So director update is like the sort of main like game logic thing. So update is the fixed update. So I just set delta time to 1/60 and frame percent to 1. I sort all my scenes by their depth, because the scenes have an order. The scene would be like the combat screen is like one scene. The pause menu is like another scene, and then there's like a transitions between would be a scene on top. Scenes are mostly independent. The game's designed so that they can't really communicate with each other easily. So a scene is like, it's a collection of components and entities that do their own thing. But I go through all the scenes. I trigger some various callbacks on each scene in order. Like always update will work even if an object is disabled, because there's some things that I need to still do upkeep if something is disabled. Like a transform component needs to keep track of what it was previous so that it can interpolate the rendering correctly. There's 3 updates. There's an earliest. Actually, there's like 5 of these. There's earliest update, latest update. Within update, there's also early update and late update. This is just stuff that happens like as you're working on a game. You're like, shit, I need something. Like scene update. Like within one scene, when you call update on this is going to say for each component in the scene, early update. For each component in the scene, update. For each component in the scene, late update. There were some cases where I need earliest update, which is like one level above. So for all the scenes, it first does earliest update, then it does that middle update step for each scene, and then it does the latest update for each scene. Just in case you had like a top level scene, like say the shared scene, I think has like the highest priority, which has like the controller processing stuff in it, because you don't want that to be different. Like you want that to persist across scene changes. So the like controller like input manager needs to, before any other scene does anything, it needs to like clear some of its data. In like a real project, like you like when you have like a custom engine, like you will just find situations like this where you're like, I need a new callback that goes in this spot, and he'll just add it. These are pretty optimized, so it's not that big of a deal to add a new one. Anyway, it does the latest update, and then it deletes any scenes that needed to be deleted, and this is for profiling, so that's not important.
Okay, so the sort of structure is that you have scenes. These scenes have callbacks, and I'm assuming the callbacks will also be on the entities as well, where you can call them. And since you start to do like, okay, here's an update, sometimes you need to have something earlier, so it's earlier update, it's earliest update, it's like super earliest update, really early update.
But these are not just like a number priority for early, late, and earliest and stuff. Like these are like there's more to earliest update than just being earlier than early update. Like so within one scene you will get early update, late update. So if you had something in, say, the combat scene that you needed to go after the transition scene, or after like a scene that would be normally on top of it, there is no way to get that timing in early update, or late update, because all 3 of these are just done in a row before going to the next scene in the list. Right? Okay. So, like, if you have 3 scenes, like scene 1, 2, and 3, in scene 2, if you needed scene 2 to run some code before scene 1 did all of its stuff, that is what the earliest update 1 was for.
Okay. And then I'm still on the thread to getting to entities and components, but feel free to like diverge as you wish. I would be like, so where are the 10 entities?
Yeah. Okay. Let's go into scene update. This macro is just what? Oh yeah, it's just it loops through the list of components that need an update for that event, and makes sure that they are in like a currently active state, and then runs the callback on them. It's a macro because there's like 20 different places where this is done, and there's some there are some booleans on the components that use this name to indicate whether or not they actually use that function, so it doesn't. Is that the case? Hold on, I'm trying to remember. Some of this stuff has been re-architected a few times. At one point, that might have been the case. I think it's building the lists without that in mind. Like it's building like the actual. Let me just find scene. Yeah. So like component callback list. Every component that needs an early update callback gets added into this list. Since this function name is here, like this variable has the early update in the name, you got to use a macro to like glue things together. I like macros. Okay. I think this is one of those things where it's like a lot of newer programming languages are like, oh, we don't want macros because you can do dumb shit with them. I like not having. I like I like being able to like twist C++ to like do what I want and like glue names together with macros just to reduce boilerplate. Like I was in.
Feel free to like, showcase the most cursed parts of your code.
But like this function right here, like this broadcast macro, like this makes sense what it's doing. It's just like, oh, this is running unlocked update on all the components. Ignore what the fucking macro is actually doing. This is a bunch of boilerplate and complexity that's just kind of just shoved under the rug so that I can have code that is reasonable to read. That's a lot of my programming style with C++, and why I like C++ compared to like C is just the easy ability to just like hide stuff like that. And that is a double-edged sword, but when you're the only person working on a project, you can do that. Like I give you permission.
Yeah, there's something.
Let's see,
there's something cool about like inventing a macro, and then like if you're on a team, it's like, okay, now I have like 4 people to convince that this macro should stay in the code base, and you're like, you know what? I don't care.
Yeah,
it stays. I like it.
Yeah. So here's somebody, and I see somebody in chat saying those could be arrays with enum names as indices instead of gluing identifiers together. Yeah, but then, so this is a function as well on a component. The function is unlocked update. Like component has a function called unlocked update. The list is called unlocked update. So it goes through that list and calls unlocked update on it.
I mean, by definition, anything that is a macro could be a code, but macro will do certain tricks on the string level. So
like function is used multiple times in here. It's used in these 2 spots, and this is like the thing that I like using macros for is to try and reduce these things where you have the same. Like this is a copy paste error. Like if you go through the early update list and call update on the components instead of early update, you're gonna, that's bad. That doesn't work. You've basically broken the point of that function. So if you can reduce the number of things that the number of times you have to type something, you can reduce like potential errors. Anyway, let's try to get the most cursed macro in the game. It's probably the component macro. Let's go into gameplay code and find something.
Something nasty.
Of course, Visual Studio doesn't like to color things correctly because that's a hard problem, I guess. What is it doing here? Why? What the fuck is this shit? Visual Studio, excuse me.
Oh, drop the color.
Why is it doing that? What the fuck?
It's every time when you scroll, it's different, no?
It's because I'm zoomed in. I like this. It's not this bad usually. Where's refresh on here? No, it's just broken.
Oh, way better.
God, I fucking didn't even refresh it. Whatever. This macro is pretty nasty. Component bleed derives from status. Let me just expand this inline real quick. Like this right here.
Class bleed component with semicolon template. Okay, class component info bleed. Public.
Yep.
This was from the tweet, no? This was like public
yeah, I'll
static.
show you. I'll go into there.
And
Yeah,
then-
static const express const character pointer const names. But I don't know. There's so many fucking when you have pointers and const like there, you have to put a const before the pointer. You got to put a const after the pointer. Constant expression. There's like 5 different versions of it. I just want to make sure that this one is a compile time thing. So why not just throw all of keywords at it? And then, okay, so this is actually not like the class definition. If we format this like more reasonably,
this is
what it is.
Forward declared.
Yeah. Forward declared bleed. Define a template specialization for component info of bleed that has the string name bleed as the
I see macro. I see macro opportunity here.
Yeah. This is so like if you do component info bleed name, you get the string. You get this string from here, which is used in some places, and then class bleed. We derive it from a class called derive component with boilerplate, which I will get to. Which has bleed status and like this is the enum entry that is generated by that Python script. Component type bleed. Here, so it's going to be number 345. Component type bleed, and then we can actually do the class stuff. If we convert this back down to the macro. See, this is a lot nicer. It's just a component definition, right?
Okay. I didn't realize he pasted this in because I said like, oh, there's macro opportunity. Like this is literally a macro.
Yeah, this was a macro.
Okay.
Yeah.
So this is okay. Making class super heavy keyword, making sure that you have a static compile time string name for it, and then like normal class definition follows. Okay.
Yeah, and I'll get to the boilerplate thing, but let me just. This is something worth showing. Let me open up the end is nice code as well. The end is nice came out in 20. Let's not upgrade this to a newer version of Visual Studio. In the end is nice, so there's a terminology change. The end is nice did not have director, scene, and component. Or it did not have director and scene. It had the scene was called entity manager, and the director was called entity manager.
Entity manager. Okay.
Yeah, but let's see. So I didn't have that. Why is everything red? It's probably because I had to upgrade it or something. Oh no, I think I'm missing the engine folder here. Anyway, in the end is nice code base, this was not a macro. The macro was here, where it was this thing. Oh yeah, I guess there's another Visual Studio. There's another SVN I needed to check out to get the definition for object ID. But object ID, this was the one that defined a bunch of static stuff and like built-in functions. There's an issue with this, which is that this data right here, cloth being a component, is duplicated here with component type cloth and the word component here. And if these do not match this, you get subtle errors that are kind of hard to notice. So one of the things for the end is not, or for the Mewgenics engine that I wanted to do is just get rid of this like duplicate like macro. Like if I'm using a macro that needs this information duplicated across it, I should just be one macro, and there should not be a chance for that error to occur. If that makes sense.
Yes. You stepped up your macro extraction game.
Yeah, stepped up my macro extraction game. So now you just make a component. A Python script finds the name and adds it to the enum so that you don't have to keep that in sync manually. This macro hides both like some meta information needed for reflection and some boilerplate information. Anyway, let's expand. So I don't have that issue where where the end is nigh, where if I mismatched the macro from the class name that I would get like a like a bug. I don't even know how to describe the type of bug that you would get. It would just, you would be like, get me all cloth nodes or whatever, and it would give you that plus the other object that just accidentally had cloth is the enum ID or whatever.
And
let's go to derive component with boilerplate.
Let's go.
Yeah, this one is going to be hard to see zoomed in like crazy.
What is happening here?
Is this one? Oh, this is part of the this is the template. You've seen this macro.
Yeah.
Impl, because there's if you don't specify component, that's defaulted. So you can do like component bleed and not specify something that's derived from it. It'll infer that it'll infer that it's from component, which is some nonsense macro tricks to get like a overloading basically. Anyway, derive component with boilerplate. This is a funny little trick. So like if I want bleed to be derived from status, right? So instead of deriving it directly from status, I derive it from this template that has bleed and status specified here, which lets it derive from status. I am baffled that this works because this doesn't seem like something that should work, but it does work. where this this is really the thing that you get out of this, is that you can have these two member field, like you have these two names brought into the namespace where you can like super and self, which are from Python. Or at least super is from it's from Python. I think it's from Java and JavaScript and stuff as well, where it's just a reference to what the immediate parent class is. Which is useful if you're changing hierarchy stuff around. For a number of my status effects, I want the initialization function needs to make sure that it also calls the initialization function of its parent. And if you're adjusting hierarchies, then you would need to maintain, like if you have bleed deriving from a status effect. I'm trying to figure out how to word this right. It's complicated. Okay, it's C++. If you have bleed deriving from a status effect, bleed doesn't have an initialization function, so it's probably a bad example. But if it did, you'd need to make sure that you call super initialize at the start to make sure that the status effect initialization function gets called as well. And if you just did status : initialize, and then you changed what the base of bleed was to, like, let's say I wanted to have all the damage over time ones have their own like base, you'd skip the damage over time initialization if you wrote status directly, but if you write super, then you don't have that issue. A lot of this stuff are just little things that make it so that when you're writing code in a certain way, you get some guarantees for like flexibility for like changing the structure of things, where you don't have to like remember every sort of, like, you don't have to remember like 20 million things that you have to double check when you change the structure, because some of this provides some guarantees.
But you still gotta remember to call super, no?
Yeah, but a lot of the game's code is structured that you don't need to do that. It's there for rare cases where you need to make sure that you call super. Like if you're like, oh, I know, like I am overriding a function that I know needs super called.
Okay.
There's some places where that's used. Self is used. Self is used in a bunch of other macros. Example here.
Oh, nice.
Yeah, so you can't normally do this in a macro without this type of like macro hack because can you hold on? This was how the old macro worked because you had to pass the name of the class into the macro so that it could put it in all of this stuff where it was needed. Whereas now, if you just have it here, you can. I don't remember exactly what this one. This is something that C++ just needs you to do to like bring certain things into the namespace. A lot of this stuff is stuff that was written like 6 years ago and slightly tweaked over time, but it's sort of like this is disgusting stuff that will make C programmers cry. The point of it is, it's just a macro. Just ignore it. You don't have to pay attention to any of this shit. There's a bunch of meta stuff for like this is all for reflection nonsense hierarchies. A lot of this stuff is there to make this as compile time as possible. Like if you type in hierarchy, then it's gonna be constant because this should be the same every time it's called. And then this was a serialization system that is not done and was not needed, so it's just commented out for now.
You have the advantage of knowing that you wrote this, and you're like, you're not cursing at this code if something goes wrong, because like you have this probably a mental model, even if it's like fading because it was 6 years ago. So you kind of trust yourself enough to be like, okay, let's do it. But if
this
you tell
is not
me, like,
that much code as well.
Okay, but then you like throw somebody into the code base. They're like, hey, if something goes wrong, just figure it out, man. And I'm like, what the heck?
Well, nothing in here should go wrong. This is a very small amount of code that does very specific things, and you use it with a macro that's kind of impossible to fuck up. So I like it's just a bunch of random complexity hidden in it. Like if you ever looked at what the fucking C headers look like what the fuck there's where am I even including this the C++ headers? Like if you looked at what like functional looks like.
Oh,
like
was
in,
this
the C++?
Was this fast find? Stuart Lynch.
Oh yeah, I have fast find.
Stuart Lynch plugin for Visual Studio. Yep. Shout out.
It's necessary. It's fucking Visual Studio is useless without it. You ever look at like one of the actual like C++ fucking headers right here? Like, none of this shit makes any sense. What is this function deallocate large default? I mean, the name makes sense there, but there's just like
nice.
Like this is what like the like call back binder sequence like. But
this is now C++.
This is unreadable.
This is STL. This is the C++. And C++.
Yeah, STL. Okay. This is like the Microsoft written code. So like when you look at this kind of shit, and then you just go back to like my thing, which is why did it close the file?
But I get
component.h.
I get what you want to say. Like you're not there yet. You have room to grow.
Next this file.
Next game, it's gonna step up.
Next game. Yeah. But yeah, so this is the boilerplate thing, and then there's like there's a macro thing inside of here.
Enumerate all component events. Okay.
Yeah. This one, let's go to peek the definition of that. This is just earliest update, early update. Just a macro that has all of these listed. These are all the ones that the engine can trigger. That need those update lists, right? So this is just defines a bool for each of those.
Defines a bool for each of those. Yeah, okay. And you get the names.
Yeah.
Okay. And
I get the names. So I get like overrides always update false or whatever. Wait, no, this is the base component type. Let me go to the fucking macro one. Yeah, where's the component boilerplate.h. So in the actual, like, in derived component with boilerplate, these bools are, they're defined somewhere. I could have sworn they were here. Oh, I think it's in, where is it?
We have Cameron in the chat who is working on MSVC frontend, and he's saying, just look at the STD invoke. And I'm saying, no. We don't do that.
I don't know if I use
Because
STD invoke anymore.
Because, no, it was like when you were comparing the macros and the shenanigans that are there in SDL. Yeah.
Where was I actually using this? Did I, like, find a different way to do this? I might have found a different way to do this. Oh, it's in create, I think.
This is fine. They are used somewhere.
Yeah.
Or they might not even be used, okay? It happens in large code bases. Things where
there is somewhere where I'm detecting whether or not those functions are overridden automatically with another macro, and because when they get added to the list, like when you create a component, which I think is in scene template, yeah, create component. Okay, here we go. I don't know why this was not showing up in the fast find unless I changed something different. I might be excluding some files from fast finds. Anyway. But yeah, so this is where it sets the bool to true. Okay, when you create a component, this is yet another fucking template. And if the component overrides update, it adds it to the update list and then marks in the component with a 1 that this is in the update list. Because later when if you destroy the component, it needs to make sure that it removes that from the update list. So it needs to know that it was added to the update list to remove it. This could probably be a constant expression somewhere. So there's probably some room for this not being not being a mutable bool like this. Doesn't really matter. So there's some stuff where it's like none of this is ever showing up in a profiler, so it doesn't matter. But this is sort of the thing that keeps it, an object that doesn't need a render event isn't going to get a render event. It's not going to have any cost on other objects that need render events and stuff. That did matter a little bit because when you start adding a whole bunch of different types of events like early update, earliest update, earliest update, or whatever, if every single one of those was hitting every single component in the game, that does start to add up for your frame time. So you kind of want to make sure that you can do that without it having a cost. So that's what this sort of...
So you're like pruning what needs to be asked for an update and all the other functions based on
like
the component.
when you create a component, the component, this macro is overridden, knows if the component had like its own update function defined.
Did you run like a comparison with this turned off completely and then profiling it and comparing it to the turn on version? Because it will be interesting to know how much of the speed up it is. Because if you don't have it overridden, then you just go and do pretty much empty function, no?
Yeah, but there's like...
but you need to go through the components.
It's iterating through the lists, which all need to be sorted as well. So it's better to have, your earliest update callback. There's like 3 or 4 components in the whole game that need to use that. So that list is going to have 3 things in it. It's going to go boom, 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 update the 3 things you need to update at earliest update and then move on. There might be 20,000 components in the scene, but they're not hit by this update function, which also like checks to make sure that they're active before updating them, like that they're active and fully created before updating them. and the those lists is also a custom data structure, which I can go over because I like this data structure.
Okay.
At some point,
we can do it before we go there. I have like a couple of like minutia questions, because right now on screen we have like templated function accepts raw pointer, but also params ampersand and dot. It's like, to what extent do you pick and choose functions from C++ when it comes to like smart pointers, raw pointers, like move semantics, passing things by like just raw stuff?
This is perfect forwarding, which is a C++ thing. Because create component is basically a constructor. It needs to forward, like create. Let me find something that actually has like parameters for it. Like create status icon right here. Create status icon, and then this is going to eventually call the initialization function for status icon, which has icon name, parent icon, and then like a parent. It has some information. Either way, these exact parameters need to get forwarded through the create function, which ends up in. It eventually calls create component, which is that macro that we're back here, right?
Yeah.
So these parameters are just parameters that need to be in the initialization function, which is called here, which needs perfect forwarding, or else you end up with another nonsense fucking C++ thing. And hey, if we have a Visual Studio front end guy here, this is my request is that I needed to go down this chain and give me the autofill for this function, and not just tell me params ... Please
say again. I didn't get it. Say again. Like what would you prefer?
Okay, so here, create status icon.
Yeah.
This is basically a wrapper around status icon init.
Yeah.
So if I do. Typing this right here. I don't want this to be params ... params. I want this to be the autofill for init.
Okay.
And I don't care if I have to like tag this function with like one of these fucking like tags right here, like a component init or whatever. Like I don't care if I have to do some extra annotation for that. I need this function to give me the actual params for status icon in it here.
Because all annotations will be then wrapped in the macro. So that's not a problem. If we have to do that.
I need these suggestions to be what the actual parameters this thing accepts are, which would be this list right here. C++ Visual Studio does that for built-in stuff in the STL.
Oh, really?
So yeah, they do that for built-in stuff in the STL. They don't do that for custom perfect forwarded stuff. That's just my request there.
Okay. So
anyway, we're deep in the worst most C++ part of my code right now still. Like I promise you, I'm just sort of like showing. There's a bunch of like complexity that's just sort of hidden in these like two files that are like every sort of game is going to have something complicated in this system, especially like, there's a lot of particularities in here where it's like I need these things to be a certain way, and just it's a lot of boilerplate. And I just want that hidden away in one macro that I don't have to worry about.
I see two threads now. Either we like finish the entities and components to have like a clear picture, or we go to the component list, the fancy data structure. Where do we go?
Yeah. Component list is, let's see. Let's go to component list. I think that this is I've pretty much covered what there is there.
Okay.
What did I call it? It was in the scene. component callback list. A flat set? Why did I call it a flat set? I don't know. Anyway, this is basically so this is a list of pointers, and it needs to be sorted with a component sort function. Because all the components have a sort order defines, which is they can override, they can add a priority, and if the priority is not set, then they're sorted alphabetically by component name and then by creation order. That's all in the sort list. Now, for a while, this was just a standard set because that does what you want. You put objects in the set, you can iterate through them, and you can iterate through them in a sorted order and do stuff on there. Now, as it turns out, when you start having if you have 20,000 components in a scene, set starts showing up in the very slightly in the profiler. Just the iterate. There is some cost in iterating over a set. There's some cost in adding stuff to a set and removing stuff from a set. So ideally, it should just be identical to iterating over an array if you're not adding stuff to the list, right? Like this is more of like an array that is always sorted than a set, where calling sort is also a fairly for this case it can be pretty expensive because you're doing it. There's like 12 callbacks, so you'd be doing it like 12 times a frame on like a list that potentially has a large amount of things in it. So I needed something that it's an array that's always sorted. So the way that this structure works is that this structure has two sort of things. There is a portion of it that is the sorted list, and then there's a portion of it that's the unsorted objects that you've just added to the array.
Okay.
So let's say you're 20 minutes into running the game. You might have like 600 items that have already been in the list, are already sorted as they should be, and are updating normally. You add 5 objects this frame, so you're going to have 5 objects in this like unsorted list right here, right?
Yep.
When you update, like when you call update, this has a like a for each, like a special for each function where it'll iterate over every object in the array in order. What it does is it sorts just the new objects that have been added to the array, which is this chunk at the end. So you call update, like you call for each and then pass it to update function. It's going to be like, oh, I have 5 new objects that are not sorted yet. It sorts this list of 5 objects. You now have 2 sorted arrays here. So it sorts this one right here. You have 2 sorted arrays here. And then you can just merge them as you're going through the list. You then have you have your back buffer array, which is unsorted, which is now like this size right here. And as you're iterating through, you just basically do like you do in a merge sort where you compare the front. You like look at the front one here and the front one here, and then take the lesser of the 2, call update on it, and then move it over to the new sorted list. And then you'll have all your objects sorted again. So like there's a double buffer thing here.
If you mentioned it called like 6 times per frame, then the first one, it's called, it would sort it and merge it. And then because there's no new stuff, you just keep iterating.
Yeah. And when there's no new stuff, I believe, yeah. So the for each actually like, so if the unsorted list is empty, then it just does a normal for each loop where it just goes through the list, makes sure it's not a null object, and calls the function. But if there is stuff in the unsorted list, then it does it does sort and then the merge thing as it's moving it to the new list.
Why?
Now, the only thing that makes this deletion is more complicated on this than you would think. But we don't need to worry too much about that.
Why it's complicated? Like 2 sentences.
So deleting an object from an array is not a cheap object because if you want the array to not leave tombstones behind. So I change them to null. When the pointer is set to null, the comparison operator doesn't work anymore.
Oh.
Yeah.
So what do you do?
Because some of the data for the comparison is inside the object that's being pointed to. So I set them to null, and then during the merge operation, I skip over the things that are null. But in order to find the object that you need to delete, you need to binary search. And so when you're binary searching over the list, if you hit one of those null nodes, which you cannot compare against, you have to scan forward or backwards to find one that's not null. So if you have like a large block of null objects in the array and your binary search hits the middle, you end up with a linear search there.
Oh, okay. Okay.
Yeah.
So like for players, if you have many enemies that have many statuses, meaning components, and you kill them all instantly, you have a linear search.
That's not going to matter for this. It's more like if a whole particle system is destroyed. If you're deleting like 20,000 things all at the same time, I have a different function for like a mass deletion, because if you're deleting 20,000, it makes more sense to mark them as deleted and then iterate over the list and then erase them all than it does to try and binary search to find it in the list and erase it all. So that's why I have like an erase if here as well.
Why the components should be sorted in the first place?
There's a lot of reasons why the components should be sorted. The most important one is that this gives you deterministic behavior in game. Like that's sort of the main reason why. Like you want to make sure that if you have your character does like it's hard to give examples of this with Mewgenics because it's a turn-based game, but for like the end is nigh, you want to make sure that your character updates before the camera follows the character, for example. So you want to make sure that the player character is earlier in the component update list than the camera. The second reason why they need to be sorted, or why they should be sorted, is because all of my components are allocated with a special allocator as well that tries to keep components of the same type together in memory. So like every status effect is going to be grouped together as a status effect in memory, and these update lists, the creation order should roughly match the order that they are in memory. So you get good memory locality when they're sorted and you iterate over them in order. For like you will hit all objects of one type and then all objects of another type.
We gotta see custom allocator, by the way. This one.
Yeah, custom allocator. It is. Let's see. This is virtual generational allocator. This one's gotten more complicated over time. All right.
Okay.
Virtual memory is crazy. There's nothing like built in on C++ that deals with it. But I believe this is 1 gigabyte, like a billion. Yeah, it's like 1 gigabyte worth of memory per object type. A virtual address space.
Yeah.
Which you saw that list of like component types that had like 3,000 things in it. Each one of those is reserving a billion, like a gigabyte worth of virtual address space. Somehow the game does not use 3 terabytes of memory though.
And that's an exercise for the reader. How does it happen?
Yeah. How does that work? It's kind of magic, isn't it? But the point is you get like an array that's a billion long where they're never going to be moved around and everything in this array is going to be contiguous. So it basically it allocates a big block for each component type like that. And then it's like a very standard, after that point, it's a very standard allocator where you have a list of free blocks and then it just points to the free blocks and stuff like. this is not going to be that much different other than the fucking like the generational part, which is that there's 8 bits or 8 bytes at the start of each block that represents a generation. So every time that memory address is reused, the generation ticks up by 1, which helps me detect whether or not an object was actually deleted, like if I'm pointing at an old version of an object or not.
And it's reused when you delete more often than when you reach the end, right? Because it's a billion.
Yeah, no, it's when you delete an object, then that block is reused again.
Okay.
So if you like create a bullet, the bullet will go in block 1. It'll be marked as generation 0. Bullet will hit something. It'll get deleted. That generation, when it's deleted, will tick up to 1. So now generation is 1. Anything that is pointing at that bullet knows that it was pointing at that bullet's address at generation 0. So because that generation is now 1, it knows that the bullet is dead. Like the pointer to that bullet.
Okay.
It knows the bullet's dead because the generation does not match what was stored. And then there's I have another, ref.
And then when you allocate, you look for, if you bump the generation, then how do you know that it's empty?
That's just a normal free list stuff. Like you have, there's a free list, which is just a link to list. Like each empty space points to the next empty space.
Okay.
So then, and it points, the allocator points to the first one in the list. Or it points to the top of the list. So then, when you allocate, you just take the one that's at the top. The data that is in the block should be this pointer, which is next buffer, or next bucket. Is that right? Reserved block.
You have a buffer and a pointer.
Yeah, that part of it is a standard thing. So if you just look up like a free list allocator, that's not too different from what other things do. Some of this stuff, some of the reason why there's a bunch of raw pointers in here is because when you put too many templates in here, you get like a function explosion of like templates and stuff. So this somewhere in here, yeah, like the allocator itself needs to just get the object size passed. At one point, this was templated to use size of object, but then what would happen is every single object had all 7, 8 of these functions template specialized, and you would, where it said like 121,000 functions compiled, that would be like 500,000, and it would take like 4 hours to compile.
And we like fast compile times.
Yeah, fast, as in 1 minute long, as in buy a $4,000 computer just to make compile times twice as fast. Yeah.
Okay, but tangent. Have you went with like hyper optimizing compile time or not? Like, because you can do, forward declarations for things so that headers don't include headers. And like, did you do it or?
Precompiled headers handle a lot of it. I've done some profiling for it. Like there are a bunch of cases in this code where I'm like using void pointers where the correct way to do it would be to use a template and not a void pointer. But the template would cause like an explosion of like function specializations because of the templates. And the void pointer doesn't. So there's some cases where I did that. But you just buy a better computer, right? It makes the game compile faster. Like compiling is one of those things where you just throw more cores at it, it does get faster.
Yeah, and you don't have
it is one of the worst
1,000
parts.
engineers and 1,000 laptops to buy PCs.
Yeah.
So.
Yeah.
All right. I have grilled you for 90 minutes. There's still stuff you can show if you want, but there's a bit of Q&A lining up already. So
Yeah.
how are you on the stuff that you wanted to show?
I don't think we've showed that much at all. I've kind of just only showed like the entity component stuff. Like we've not shown any gameplay code. I haven't shown any rendering stuff either. There's a lot. I mean, look, there's 6 years of. There's more than. There's like 15 years of work in this engine. So there's like a lot of.
It's gonna be tricky to showcase.
I think I should show. I should show like what a bleed status looks like after going through all the boilerplate. Because without seeing that, you'd be like, oh, there's just so much complexity and stuff. Okay. So let me see.
I mean, let's see what all of this complexity gives us when we actually want to define a status.
Yeah. All right. I fucking let's bring that back to normal. So here's what I do. I make a component called bleed. This is a bunch of meta info, like which icon to use, an AI value for it, if it counts as a buffer, a debuff.
Yeah.
I define an initialization function, a round and queued function, and on get elements, which are all in status effect. And then it's like, on the initialization of it, I add a particle effect to the character. At the end of the round, I do stacks damage, play a sound, and then the element is blood, which was not used in the actual game, so this could actually be deleted. Do 1 damage, increase stacks by 1.
What is bleed. Element? You mean like ice, like
yeah, like
stuff?
ice, fire, and stuff.
Okay.
Like blood is in the list, but I don't think we ended up using it for anything. So I guess bleed makes your character count as blood element. But yeah, you know, this is a very reasonable amount of code for an effect like bleed. Poison is similar. Poison also has extra effects where if you would receive healing, it reduces the healing by 1 and ticks down the poison.
Okay.
And that's all I have to do to make bleed. Like, all I have to do is define that function in the header and these 3 functions, and then bleed is available everywhere in the game's data to use as a status effect.
That's actually pretty neat. And then I can now understand why I have so many of the of the statuses.
Yeah.
And everything else. Wait, is it possible for you to showcase sort of turn resolution or like attack resolution and all this like components spiraling into each other?
Sure. Let's see. Okay, I'm gonna go to melee attack ability because this is probably the simplest one. Let's find basic melee. All right, here in the GON file is just don't worry about that. Here in the GON file is an ability called basic melee.
Yeah.
These are some localization keys. It says attack an adjacent unit, melee attack. This is a custom Visual Studio extension to make the reading the localization keys in code work.
Oh, okay.
Oh, I was fucking around with the code, so I was recompiling the whole thing. Oopsies. I just wanted to show what the basic melee attack looked like.
Okay, but and this is the GON file, right?
Yeah, this is a GON file.
Okay.
This will take a while to walk through everything. Like, the Mewgenics is a huge game. A lot of it is these data files, and like these are configurable in like a million different ways to get a million different effects. So there's a lot of complexity that's just like, this being a formula needs to go through a thing that parses the formula. But anyway, this is the basic melee attack that the fighter uses. Oh man, this visual NVIDIA broadcast does not like going with this. So like this fighter attack, you'll be on this tile, select your melee attack, punch, does damage. Easy enough. So basic melee, there's a template. It's based on a template called melee attack, which says this is a bunch of stuff that like how most melee attacks work. The class for the ability is called melee attack ability. some configurations for it, some default damage. Like the actual ability can be based on the template, and then all of this overrides that. So I'm going to ignore the part where I load these files and parse what template means and stuff, and just go to melee attack ability. I'm going to assume that I've been passed the gone object that represents melee, like the template merged with all this data. Which is based on ability. Or based on character. Where do I actually create an ability? Just find the actual, like, fully... Alright, character.c++ is another file that's like,
nice.
You know, a ridiculously large amount of code. I think it's like 6,000 lines of code. Somewhere in this file, it creates the melee attack and adds that data to it. There is a thing called ability, which has a bunch of stuff for abilities. We create the ability, which melee attack ability is it's derived from ability. Interestingly, these are not using the component system because the abilities are done in a different way. Like the abilities are just like an object that you tell it to trigger, and then it interacts with everything else. So melee attack ability, it loads. There's some like the data flow is weird because there's so much loading and configuration stuff. Refresh data, I think. Refresh data is where it loads all of the possible configuration things for target.
Whoa.
Knockback modes, various targeting restrictions, various AoE restrictions, some other stuff. That's loading a bunch of stuff for the ability. When you actually trigger the ability, which is on trigger, so this is called after the ability has paid its mana cost, and you and the character wants to, like, you select melee ability and select a target. The ability, it costs some resources to use, so the ability pays for those costs and then sets up a few animations and then calls on trigger, which is a virtual function. So now I have, this is where it actually plays the animation and does damage. So it has to load the animation from the gone file, which data right here is the gone file. So it selects the animation, which can be overridden by an ability. This is some random shit for an enemy that needed to do a thing. This is the damage threshold alt animations. This was in the basic one, so that the fighter can have like a bigger punch when it does more damage. I don't remember what ally animations for the cleric's basic attack, where it licks if you're attacking an ally and it punches if you're attacking an enemy. There's a lot of random configuration things in here because they're all kind of just melee attacks. Then there's some stuff for multi-hit abilities in here.
But this is
like the game is a big Rube Goldberg machine of a bunch of things going on all at the same time. So this stuff is complicated, and it's hard to walk through it like step by step.
And this was like built both like not from a spec, but you kind of played it with Edmund, and it's like, let's add this, let's remove this. So it was like probably all of the edge cases were being discovered live and adapted. So at this point, do you even have like a clear procedure step by step image of what happens when somebody attacks, or you would need to consult all the weird paths that can happen. Like, in this case, we actually added for this mini boss, we added this ability to do like a little bit of before, and like blah, blah, blah.
The code is the documentation for a lot of this. Luckily, a lot of this stuff, because they're strings, you can search. You can be like, what is damage threshold alt animations do? And you'd be like, and then it's this right here, damage threshold alt animations. Oh, if the damage is greater than the value, then you do a different animation. Like, some of this stuff is like, there's a lot of code that's just like, you read the code. I have a general idea of how it goes over in my head. It's kind of hard. It seems like a mess when you're walking over it, but the way the abilities work is that the characters have an animation queue, which has a bunch of piecewise animations in it, like play animation, move to this tile, do this callback. And all of the abilities, what onTrigger does is it populates that queue with all the stuff that the animation needs. For a melee attack, most of the time that means play this animation and do this callback at the cast point of that animation. And the callback is just do damage to this tile, or the tiles of the AoE. This melee attack ability has a bunch of extra shit in it to cover edge cases, because generally, like, my philosophy for a lot of this stuff is that you want to optimize for the common cases, but then like let there be a place for the edge cases as well. So this is construct an animation, which is just play animation, do callback at cast point of the animation. And when the cast point is hit, which is when the punch hits something else, that's what the cast point is. It then runs this lambda function, which says, for all the characters' passives, you trigger this callback on the passives, which is on ability, animation, cast point. There's obviously a lot of complexity inside of this shit right here. But all the passives that are affecting the character, it calls this function. So various effects and status effects might need to hook into this and do something. Such as cancel the punch. If it's multi-hit counter, because there's some shit in here for like if the attack hits multiple times, you need to count how many times this callback has been called. On cast point is an ability thing, which calculates the area of effect of the ability, like which tiles it's going to affect, and does self-damage and stuff. Get an ID for the attack. I don't remember what this edge case was.
Can I ask you a meta question?
Sure.
You're a single programmer on a huge project, and this code becomes like massive over time. And it's like year fourth, okay? Fourth year of development.
Yeah.
Do you have any anxiety related to, oh my God, I have no idea whether it will work because it's so messy, it's complicated, and like we're adding so much stuff, and what if it will not work out because we'll add something that just starts to fight with all over each other? It's like, is this at all in your head or not?
For the most part, this holds together. Like, I like what I've shown here, and I have not shown a lot of the cleaner stuff, but a lot of what the game's code does is that it takes a bunch of this like complex stuff and it sort of hides it in these systems that are like configurable. Like they're like, for the most part, I'm not usually touching this part of the code. There's some random edge cases that I had to fix a bug on, like, oh, this like one would be for if the cat dashes before it or gets knocked back before it attacks, it needs to recalculate the area for a multi-hit thing. And there's like, but for the most part, like a lot of the gameplay stuff is just sort of, you dig down in here, like damage tile, like there's a whole damage system for how to apply damage to things, and like a configurable damage instance that has a bunch of effects tied to it. And those things are easy. Like, it's easy to add bleed to the game. Like, I showed you that code for bleed, right?
Yeah.
Those things are very easy and clean to add to the game. The code makes sense. There's not a lot of complexity in those status effects. So a lot of the more complicated stuff that the game does is in those types of status effects because the code can be clean there. All this system stuff is like, modders will probably have some issue with how much random custom one-off things, like melee attacks are gonna accept different parameters, like what is detached animation and stuff. Like, this is not on any of the other ones. There's maybe 20 ability shells that the 3,000 abilities are all branched off of from. But yeah, there's a lot of it is just trying to keep it all in my head. It's not as hard as it seems. Like, you can just search the code base for keywords and stuff. And the general structure of it is not too bad.
Nice. No, it's like, I mean, it's a shipped game that functions flawlessly for most of the people. So like, it's by no means, I didn't mean to say like, oh, it barely holds on together. It's like,
no, people should understand that most game code is going to be some version of this. Like if you're making a game that has any complexity to it whatsoever and is not like a step above tic-tac-toe or whatever, you're going to have these sort of things where they're like it's like a record of like the problem solving you had to do while working on the thing. Where it's like, I need this thing, and especially for this game, which was a collaboration between me and Edmund. Ed is not a programmer and does not know like how the code's structured. He can't read the code, or he can't read the C++ code. He did eventually start getting into like the GON object stuff, which is the stuff that's meant to be more human forward. But there would be a lot of cases where he would design something and I would be like, how am I gonna fucking fit this shit in with what I've done? And then I either have to redesign it to fit, like, I'm trying to think of a good example of that. There's like the enemies that turn into rocks, that disguise themselves as rocks. Ed wanted them to be invisible originally, and I'm like, well, we can't do invisible enemies because the targeting system for the abilities, it has a bunch of, like, you can sniff out invisible enemies because an ability will be like, this needs to target an empty tile. Or, you know, this is a movement ability that needs to calculate its path, and the pathfinding would know where the invisible enemy is, so you could look at the pathfinding and see where the invisible enemy is because you can't actually be on the same tile as it. So an invisible enemy does not work in the game for various reasons. But, you know, after like brainstorming about that, I was like, well, I could just disguise it as a rock, which basically solves all that issues because you still have the thing existing physically on the map. So you don't question the fact that your cat is pathfinding around a rock. So there's a lot of like, sometimes I need to like fit stuff into the systems we have, and then sometimes it's like, fuck it, I'll just do a custom thing. Like there's an end game boss fight against the mother. And it grows these tentacles out that pick up cats.
Spoiler.
Actually, spoiler. It's not, the name of that one isn't really much of a spoiler, but actually I designed that boss, so that wasn't Ed telling me to do something weird. That was me being like, yeah, I could probably do this, and then since it was such a late like dev boss that I made, I'm like, fuck, it's just gonna be entirely custom. Let me find it actually. The mother. So yeah, the mother has mother grow control. This is just like a passive effect that just does like the entire AI and like everything that the boss needs to do. Like, it's just whatever. I'll just code something like custom for it, rather than try and figure out how to add targeting modes that are like for like, there's no way to make an ability that's like, what's the target for this ability? It's the 4 closest tiles to all the tumors to enemies that to your enemy cats, but like spread out a little bit so it's not like all clumped together. It's like, yeah, just code it in C++ where I can actually like express things. This is the most like custom fucking thing. Check connectivity. Trigger grow, just a bunch of nonsense. This is more like reasonable code that is readable. Like, you know, it's a lot of code. You just show a bunch of code to people to be like, yeah, whatever. But like, this is, you can read this function and see what.
Yeah, that's like for loops, if statements, and you can
loops, various obvious functions that know what they need to do. Shuffle the array, sort it, and then I have comments. Grow all the small tumors, spawn new tumors.
Okay.
Some others. Yeah, it's a lot of code, but like it's just C++, so it's expressible. You know, you can read it as code.
Nice.
Most of the game code is more like this than the nasty like forwarding things throughout the system and registering callbacks and whatnot.
There are some questions about like the entire systems, like rendering. So
yeah.
First of all, do you want any break? Do you want to, like, are you good? You have something to drink? Do you want to have like time to breathe?
Yeah. I think let's keep going.
All right. Then we can sort of aim to have like 30 minutes, 40 minutes, something like that, and then wrap up. Okay. So there's already a couple of questions, so gotta be sort of quick on time. But there's already a couple of questions both in the chat and on the website about rendering. So since this is like custom Flash technology, we can't just like skip it. So can you say a couple of things or show some of the key parts about the rendering?
Yeah. So this is a thing for a 2D game. Rendering is going to be the bottleneck for most custom engines. Rendering is the bottleneck, and it's such a big bottleneck that most of this other stuff doesn't really matter for performance. For rendering, let's see. I have let me just find render. Not renderer ISO. Renderer. Yeah. So I'm trying to figure out where to even start. It's like so. I'll go to the Flash file stuff, which would be in.
So for context, as far as also I remember from our last discussion, you have got the PDF of a Flash spec, and you went through and implemented pretty much an entire Flash pipeline, like rendering pipeline.
Yeah.
So vector graphics, which is unlike, for people who might not be familiar, it's unlike the graphics you see in any 2D games, which are mostly bitmaps, and you don't do really much vector graphics. But now this vector graphics Flash engine, it became kind of a cornerstone of you and Edmund's style of games. So people recognize this, and this Nye or Binding of Isaac, they look very much similar to Mewgenics.
Mm-hmm.
Now, what was the school view you showed? The debug
That's
view?
the wireframe view.
Can you show it again? Nice.
Yeah, it's a wireframe view. So like this is how all the art in the game is rendered. All the Flash art gets imported and converted to polygons, and drawn as polygons.
Nice.
Yeah. Flash is interesting. The file format is documented pretty well. Although Adobe's removed the PDF, so you have to find it from elsewhere. Let's see. Flash. Where the fuck do I even start with Flash? Where the fuck is... there's a file called swf.h somewhere in here. Okay, yeah. swf.h. There's a bunch of configuration stuff. Basically, load the file, the Flash file, which I have a decoder for it, which... let's just go to the define sprite, I think, is the interesting one. So there are a bunch of, like, these structs are basically one-to-one from the document that defines, like, the Flash file format. And then loading them isn't too hard because you just kind of, like, follow what it says in the document for it. So define sprite would be I always use release config. Oh yeah, no. I see a chat on YouTube about that. I have debug, release, and distribution. Release is the one I mainly dev on, and I switch to debug if I need to step through the debugger for a reason. And mostly because it takes like 20 seconds to load the game in debug mode. But yeah, I read the sprite data. There's a place where I process it, and yeah, a lot of this is just fully like you just read the doc. You read the Flash spec. And it's like, all right, there's 5 different types of place objects. I think there's a place object 2 somewhere. And then, yeah. This is reasonable. Like, there's not like... This part of the code base is like the reasonably written code where like this could be C if you wanted it to be, other than the fact that I use standard template vectors in places and whatnot. Actually, is this a pod vector? No, it's a standard vector.
What's a pod vector?
Yeah, where I load them on. It's a custom one that I have that plain old that doesn't need to use destructors or copy constructors. It'll just mem copy stuff around.
Okay.
So if any data is only basic stuff, I can use a pod vector instead of a normal vector, and it gives me some extra things.
Okay, but for the rendering part, you have a Flash file, you load it, decode it, put all the things in memory, and then what happens? You have the wireframe thing, you have polygons.
I have the wireframe, which would be a vertex buffer. I use OpenGL. So let's see, I have a thing in here for there's a thing called a Mondo buffer. I don't know why I called it a Mondo buffer, but it's basically I allocate a buffer with this many vertices and this many indices, 4 times as many indices as vertices, I guess. Just I don't know what number this is. It's like one of the power. I think it's 1024 times 1024. Where did this number come from? Why did I not write 1024 times 1024?
Because it's faster. Because you don't need to perform the operation.
Yeah. I should have run 1024 times 1024 there. Anyway, but it's like a giant block of vertices and indices, and it's treated like whenever I allocate, like in game, when you see one piece of the like this little food thing or this little coin thing, there's only like 20 vertices or indices in those. It places them into one of these large buffers, and so like you'll have like a block of vertices and indices in this large buffer that is that coin, and then you'll have a block of vertices that is like cat face number 32 or whatever. And when the game wants to render, when they're all in the same vertex buffer like that, one of the things you can do is that you can batch all of them together. And that is a pretty big deal for like reducing draw calls. You don't need to switch states between rendering, say, the food pickup and like the fly that's flying around the backgrounds, because they're both the same vertex buffer. Which I have in the OpenGL. No, it's in draw calls. Yeah, draw calls is like this is one of those things. I didn't have this class or this system in the End is Nigh, where in the End is Nigh it would just you'd say render this piece of art or like this art asset, and then it would do a draw call to render it. Draw calls are very expensive. If you've done rendering, like that is sort of the thing that you want to reduce as much as possible to make your game render fast. So like one of the things that I did in this was that instead of just having the art just render itself directly, instead in the Mewgenics engine, it goes through a system called draw calls where it like collects them. Like it just says this thing needs to be drawn here, and then later on the game will figure out what that means.
It's like a command buffer style where you prepare the commands.
So, yeah. Where like if I call draw, and then if draw calls are disabled, it doesn't do that, and then I push a draw to the buffer, which finds the information that it checks to see if the draw call is groupable with the previous one. And if it's not, then it starts a new batch. This is some random OpenGL sync thing. Draw elements index. This is more standard OpenGL-ish stuff. So the mesh identifier would be if it's exactly the same object being drawn, which happens a lot in particle effects. Like a particle effect, you might just have a bunch of the same circle being drawn on the screen at once. And if that's the case, then you can do an instance rendering where you... yeah. A lot of this stuff I just have to like Google when I'm writing it and make sure it works. But there's instance rendering where it's exactly the same and you say draw this object 20 times and that's it. But then there's the indirect ones where you put all the draw calls in one array and say do 20 draw calls or whatever. Draw 20 objects from this buffer. Copy over the matrix information that's needed and like the other matrix, color transform, and then depth bias, which is something else. This is for profiling. If there are any draw calls in the queue, it just sets a flag. And then there's like a maximum number that you can group before the buffer for draw calls runs out. And in that case, you just have to draw what you can and then start over again. This had some issues for a while, which was annoying to figure out.
There's also a perfect connection to a Flush song from Mewgenics soundtrack.
Oh yeah, Flush is in here a lot, probably.
I love that song.
Yeah, that seems to be one of the more popular ones. All the songs are good.
Okay, I think we gotta cut rendering short because like there's so many things.
Maybe they could go into it for a while. There's a lot.
There were already a couple of questions regarding the libraries and the setup you have. I think I've seen like SDL. So what do you use? What do you base your work on, and what do you use like raw? How do you do it?
I use SDL for most of the platform stuff, like say opening a window. Input is like gamepad input is like one of the things that is so annoying without SDL that like even people that don't want to use SDL will still like grab the gamepad stuff from it because they just have like a database of mappings for every game controller out there, which is what you need to support gamepads correctly. It's basically that. I use, like, SDL is used to open a window and do input. And then F audio is used for audio output, which goes through SDL. That one's open source as well. I've contributed a bit of code to F audio because I like it. That's the audio mixer. Those are like probably the two most important pieces of like open source code that the game's using. Everything else is like smaller things like, oh, it's a hash map that's faster than the C++ one, or there's triangle tessellation library that I use to triangulate the art from the SWF files. I don't need to write that algorithm myself. It exists. Somebody else has done an optimized version of it. Sure, I'll use it.
Do you use get text? What do you use for localization and translation?
This is a custom thing.
Okay.
The text is also Flash has text files, so I have a bunch of freaking text box support in the Flash file, in the Flash renderer, which is one of the more complicated things because this one's not documented well, and you just kind of have to see how shit looks. I can show. That's what test word wrapping is, was just finding
nice
various ways to various odd cases for word wrapping. Localization would be here, which is just a file that loads the localization spreadsheet. And then when I need to display a string, I call it's just a global. I call strings.get, and then I can get like I get the wide string version of level up prompt chaos, which would say choose something whatever, and then yeah, I don't know. It's not like this one doesn't seem like that interesting of a system to me, but it's hard to like talk too much about it.
It's fine. That's good. I needed to get through the questions of like what is custom, what is this. You mentioned triangularization library.
Triangularization.
Yeah. And there's already a question, what kind of library?
libtest2. Yep. libtest2, what does it do? It says I put all the paths into the format that libtest2 wants, which would be a test tessellator. Like this is from libtest2. This is not my own code. You put all the high quality passive things to it. You add everything that you need in there, and then you pull out the triangles.
Nice.
Yeah.
Could the PDB file be released at some point? I'm assuming for modding. Question mark.
If they want it, I can upload it, but it's a very large file, so I don't include it in the Steam build. It's like 300 megabytes or something. It would also have to be different every time I do a patch.
Why would people want that?
I think it's for reverse engineering code, like getting names of functions and stuff.
But it's still limited. Like functionality you get from this. You don't get a full view, or do you?
Don't get a full. It gives you like the names of the functions, I think, which is what people want. Because I've seen some of the reverse engineering they're doing where it's like function 24 where it does this and calls function 32, and they have to like guess what the function does based on the disassembly of it. Whereas if I just say, oh, this function is named calculate inbreeding or whatever, then they'll know what that function does without needing to like read the assembly and try and assume what it does.
What kind of workflows or processes do you have tied to the version control system, SVN? Do you do any kind of build system integration, automatic testing, and how does it look? Oh, there's also another question about testing. How do you approach testing?
Oh yeah, people probably want to see the fuzz tester. But like for the SVN, the only thing I do for version control is that I download our design spreadsheet from Google Sheets and check it into version control. And then I think I also, what do? I save the most, like the 10 most recent PDBs in a folder, in a local folder, in case somebody is like, this game crashed, here's the crash log, because I need the PDBs to resolve the crash log to something readable. So I just saved the last 10 commits worth of them. With the thing. What was the other part of the question?
About testing.
Testing. Yeah. I don't do unit tests, but what I do have is fuzz test fast. Oh, not level. I meant to do fuzz test fast levels. Where I just takes off the frame rate limit, and then runs the game as fast as possible with randomly generated cats in random levels.
Okay. But
and it just does this, and if it crashes, then I get the random seed it used to create the test, and I can rerun it and debug it.
But this is the same level, right? I mean,
oh yeah, no, I think I fucked up the commands. There we go.
Okay.
Yeah, it'll just go through every level in the game randomly and like just test a bunch of random shit against everything. Sometimes like that the point of the fuzz test, because I can run this overnight, and every time it crashes, a Python script will save out the most recent random seed to a list. So then when I wake up in the morning, it'll give me like these 5 tests crashed or soft locked, and you need to investigate them, and then I investigate them that morning. But it can run this overnight, and the goal is to cover as many different like combinations of abilities as possible, in as many different scenarios as possible. I think I have hard mode on, so it's actually
also spoilers.
I don't have hard mode on. Yeah. Oh, this is mega spoilers. Like this is gonna go through every fucking level of the game. You're gonna see everything. But you can just run. I can just run this. This system right here is one of the main reasons why I would hyper optimize certain parts of the game engine, because the faster it could go through this, the more bugs it could find. Right now, it's running kind of slow because I have this fucking NVIDIA broadcast thing running.
At what stage are you with bugs in Mewgenics now? Like, do you see the end of them, or
I don't think this game's ever gonna be 100% bug free, but just because of how big and complicated it is, like people found obscure crash bugs like a month and a half after the game came out, and I know that's been like 50 million hours worth of playtime on Steam or something like that, where they to find a unique bug. So there's just going to be stuff that shows up. It's kind of hard to dig through bug reports because there are a lot of bug reports that are not really a bug, but more like a disagreement over how things should interact. Like I think some of those, it's like, oh yeah, maybe those things should interact this way. Like I think people have brought up the fact that snow does not turn off heat wave in the desert, which is sort of like that's not really a bug. That's more of like this interaction should be different suggestion. So, but people don't like distinguish between that because things are usually just like a bug or intended or whatnot. So that makes some of the bug reports hard to dig through, because there's some where it's like, oh well, I have these two items and these are doing this and this thing when they interact together, and that's I wish it would do they do A, I wish it would do B instead. And some people will interpret that as a bug, and some people will be like, oh no, it makes sense that they work this way or work that other way. But there's just always going to be, with how big and complicated the game is, there's always going to be stuff like that happens.
The fast tester is like has this like hypnotic element to it. You could just look at it and it's like, oh, are they gonna win or are they gonna be nuked?
Yeah, it's funny because like the fuzz test version of it, half of the time it lets the cats use AI, and half of the time it lets them do like random targeting, like fully random targeting. So when you see a level that takes longer, that I think that usually means that it's doing the fully random targeting, because they're just going to be like casting lightning bolt on an empty space a million times. Whereas the ones where they are tagged to use AI, they will actually try to like fight the enemies, and can be pretty good at it or pretty bad at it.
That said, we didn't talk at all about AI. How does it work in Mewgenics?
Yeah, the AI works. I mean, it's a very brute force AI. Okay, like if you have an ability that's like, say, Fireball, which targets an area, does damage, and does effects, all that it does is there's an evaluation function for how good this damage is. Like, you damage an enemy by 3, you'll get 3 points for that. You damage an ally by 3, you'll get like minus like 2.8 points or whatever. There's a bunch of weights that you can define in a GON file for various different types of like AI. But that's basically it. Like, it'll say Fireball at this location will do this amount of damage to these things, and you get a score for it. Then it'll just check every tile that the cat can move to, and every tile on each tile, it'll check every tile that is in range of Fireball. It'll do a pretend cast of Fireball where instead of doing damage, it just records the amount of damage it would do, and then it just picks the best option, the one that has the highest score. It's very brute force. A lot of these passives have a tag. Don't need this anymore. Like, you'll have, let's say, Thorns. I guess Thorns doesn't. I think Brace does. Yeah, so Brace on receipt. Like, Brace is the one that reduces physical or reduces damage by 1, but not greater than 0. So this tag right here called speculative. When this damage callback is called, if speculative is true, that means that it's the AI doing the damage and not like a real damage. So Brace will not actually do damage reduction unless the AI can see the brace, which is basically allies will see the brace on each other, but enemies will not see the brace on you. Okay. So then if it's an AI check, it's basically ignoring brace. Which is there's game design logic behind this, which is so brace reduces the amount of damage you take. I think Thorns is handled somewhere else, but that is also like Thorns deals damage to the thing that attacked it, so you don't, and like dodge chance as well. A lot of these effects, the enemies purposely don't see it, because if the enemy does see brace, it's just not going to attack you. Like, it becomes basically untaunt, right? I don't know what the opposite of untaunt is. It becomes stealth, yeah. Because like, if an enemy thinks that it's going to do 0 damage to you, it's not going to attack you. So if you have an effect that's like, you take 0 damage this turn, the enemies would just ignore you entirely without this sort of check that says only run this if the AI can see it. Which you want your allies to know that you are going to take 0 damage this turn or whatever. because the allies might be like, oh, my friend is not taking damage. I can include him in the area of effect fireball and not worry about it. But we didn't want all of the status effects to just turn into stealth, where enemies would be like, well, I'm not going to attack you because you have thorns. So you have thorns, you want an enemy to attack you and take damage from thorns. Like, that's why you get thorns. So the enemies have to not see that you have thorns. But that's basically how the AI works. There's a bunch of weights. Like, if I find decisionweights.com.
So AI is making a list of potential moves and then checks what gets the best score.
Yep. Like, here's the default decision weights. -1 point for damaging an ally, +1 point for damaging an enemy. The damage ones and the heals, these are multiplied by the amount of damage you're doing as well. Kill enemy, kill ally, it's like 0 points for, like, this doesn't mean, this is added. These are all added together. So this just means that the normal AI is not going to value getting a kill over just doing damage.
I would swear this is valued at like 100 at my runs.
There are some enemies that do. There are some enemies that do that. I think Copbot. Copbot damage enemy corpse is set to 999. Yeah. Which is a funny little thing. I think the thing that happens is, the default ones do not value getting the killing blow. The damage multiplier means they do tend to value backstabs because that increases the amount of damage you do. Yeah. But most of them don't care about getting a killing blow. I think Pishi does care about getting killing blows, so that's why Pishi has
a lot.
The enemy. Yeah, but the normal ones don't. The normal ones also have a small negative weight for damaging themselves. And they don't. The damaging corpses is weird because there's also there's in the actual AI code for them. If they're stuck in the tile that they want to move onto has a corpse, they rerun the AI with the damaged corpse set to 1. So that's why enemies will sometimes hit corpses on the ground. That's because they can't move where they want to move, but they could if that corpse wasn't there. So then they hit the corpse.
But it always looks targeted.
Yeah.
Intentional.
Okay. But yeah, this is basically, these are the weights that determine the AI, and then there's a different set of weights for like where I want to move. So like keep distance. There's an enemy that wants to not be immediately next to an enemy. It wants to be its move range away from an enemy. But yeah, that's how the AI works. Very brute force. When you have a 10 by 10 grid and there's only 100 tiles, brute force mostly doesn't have issues. There's a few cases with like lightning conductivity that I had to like optimize specifically so that it wouldn't lock up if the map was full of water and you had like a giant AoE lightning effect on a huge move range cat where you're starting to hit like 100,000 AI checks or whatever. But for the most part, it's instant.
Last question from the chat.
Okay. Yeah.
Did you use the fuzzer for balancing the game?
No.
Why?
Fuzzer doesn't do a good job of balancing the game. It just finds soft locks and crashes.
But if you set the AI to handle both cats and enemies and you run, certain scenarios, you probably could find out that they're like overpowered or...
Oh, no, I was keeping track of that when you run it overnight. Like, it keeps a spreadsheet of win rate for abilities. It's just that's completely and utterly useless because the AI doesn't really know how to sequence stuff correctly, and there's a bunch of abilities that it's not good at using. But what that does do which I had caught bugs with this before, is that you run it overnight and you're like, oh, this one ability has 100% win rate. That's weird. And then you're like, oh, this makes you literally unable to die with this this one ability. It was one of the like cleric revival abilities or whatever was accidentally like always reviving you or something like that. So you could never actually die. So then it gave you 100% win rate or whatever. That's mostly what it could sometimes catch. But the balance issues with the game, like the balancing stuff, is much more complicated than anything you could do automatically. Okay. Like there's 2-piece infinite combos that are pretty easy to assemble, but that the AI is not good. Like there's one which is getting nerfed in the balance patch, but there's the fighter passive Merciless, which is when you do 10 damage or more in one hit, you refresh your movement ability, and then if you have some way to make your movement ability deal damage, which there are, and you get it over 10, then you just can use that infinitely. The AI is not good at that. And also that's not really that's not a detectable infinite loop, because it'll kill the enemy and then you'll win. So it ends in that way. Versus some infinites were more like, this enemy will spawn a fly, kill the fly, spawn a fly, kill the fly, spawn a fly, kill the fly forever. Whereas those are like soft locks, which are detectable because it goes forever. But yeah, balancing is also quite difficult.
I can imagine.
I don't think there's no... Yeah. I've talked to the Slay the Spire guys who collect data for all their cards on like win rate and stuff, and they make balancing decisions based off of that, which probably would not work for Mewgenics, because the balance is more in the RPG like progression than it is in the individual items and abilities themselves, where it's like there are abilities that are, if you, at the start of the game, when your cats have like 5s in all stats, there's abilities that are like pretty good and useful at that stage of the game. And then when your cats you've like hyperbred your cats to have 7s in all stats and like mutations that make them up to 10 or whatever. At that stage of the game, like the balance of all the abilities just shifts around. It's entirely different from the from the main part of the game, like the early part of the game. So things that were like strong at the beginning of the game are now weak, and things that were weak at the beginning of the game are now strong, and it's everybody's at like a different part of the game, so that starts to get like hard to figure out exactly. There isn't like data that would help with that.
Yeah, and just sheer number of combinations, because like I am assuming you can have different classes, pick different abilities and pick different cats, and now this is just like good luck. Just balancing one level, with all the possibilities. It's like,
and then there's also like there's a bunch of abilities that there's like different ways to use the same ability, and people will focus on one part of it but not another part of it, or they'll be like, I don't know what this does, but then there's like a thing that you can do with it. It's like there's the tinfoil hat is like a current item that's like basically nullifies madness, but there's a lot of effects in the game that are where madness is such like a hard status effect to work around, that we tie some pretty strong effects to stuff that has madness. Like Blood Frenzy basically just gives you infinite turns, but you have madness on them. And that's like the balance of that, is that, okay, this effect is hard to work around. It is a dangerous effect to have, so you get a crazy strong buff in exchange for having madness. And then you just get this item like a tinfoil hat, which makes you immune to madness, and you're like, oh, now I'm taking 10 turns around and not having madness. So I get this like the strongest possible effect in the game without the downside of it.
That was a hint how to play Mewgenics.
Yeah, we're not gonna like we're not removing the tinfoil hat. Don't worry about that. We like when people can have fun with the game and can do cool things and can be like, oh, there's a way to do stuff with this stuff that I wasn't thinking about before.
Nice.
We like that. I like that people like can eternal servitude bosses and take them to other bosses, even though I'm pretty sure that was
Not
an
intended.
oversight. Most of the other charm effects most of the other capture and join your party effects excluded bosses. There's a bunch of them. There's like the persuasion bet, and there's the medic or the cleric convert. Those all exclude bosses. I accidentally didn't do that on Eternal Servitude, and I don't think I can ever remove that or fix that.
Now it would be like
it would be a bad idea to do that, because that is like a high point in a lot of people's runs. Is like, oh, I stole this boss and took it to the final boss with me.
Yeah,
but that's just how it is. It mostly doesn't matter that much for balance wise, because like getting a free win isn't really that big of a deal. Like, you can get a free win, that's fine. The things that are on our radar for balance are like, this permanently makes it so you always have this combo on every single run, and it turns every single run into a free win. Like, that's the type of thing where it's like, we don't want you to like hyper focus on the same thing every single run consistently.
Makes sense.
Yeah.
Nice. Awesome.
Mm-hmm.
Tyler, thank you so much for joining me for Mewgenics source code review. I enjoyed the static const, expr, const, car, star,
we
const.
spent quite a lot of time on that, didn't we? People might get the wrong idea. There's like 3 or 4 files in the game that have like that level of like ridiculous code, and it lets everything else be nice and readable and clean like this, like all these status effects.
But then like everything piles up like in Mewgenics the game, which is a perfect analogy.